Hi, in this video we will learn how to find the volume of a solid of revolution obtained by rotating a region about y-axis. Well, consider that we have a curve which is the graph of a function of y, x as a function of y. So something like this. And we consider the region between this curve on the interval AB and x-axis, y-axis, sorry. So this region. Then we start rotating this about y-axis. Well, this is going to give us three-dimensional objects like this, which is again an object of revolution. The question is, well, what is the area of volume of such an object? So the volume in this case, the formula is very similar to what we had before. So it will go from A to B of pi fy squared, the function squared, dy. When we obtain the object by rotating a region about y-axis, the integral which gives us the volume is going to be a y integral. So we write the x as a function of y, square it, multiply by pi, integrate with respect to y. So let's see this in some examples. Yes. So we have y equal to x cubed, y equal to 1, and y-axis. So let's see what kind of region is this. Okay. Y cubed is something like this. Yes. Y equal to 1. Let me just draw it from here. And y-axis. So all these three. Okay, so the region is this guy, and then we rotate it about y-axis. So what we will get is a solid ball like this one. Yes, and remember that this was y0, 1. And now we want to find the volume of that volume. Since it is about y-axis, so everything should be in terms of y. The bounds, yes, y goes from 0 to 1, so 0 to 1. The function must be x as a function of y. Here, y is equal to x cubed. We can turn it to x is equal to the third root of y. So pi, third root of y squared, dy. Pi fy squared, dy. Well, this is pi goes out 0 to 1, y to the power 2 over 3 dy, and this gives us 1 over 2 over 3 plus 1. This is power rule. Goes from 0 to 1. And that is pi 3 over 5 1 to the power 5 over 3, okay, minus pi, again, 3 over 5 times 0. Well, the final number here is going to be 3 pi over 5, the volume of this object obtained by rotating about y-axis. The other example, first sketch the region that we are going to rotate about y-axis. What is this region? This region is enclosed by a 1, 2, 3, 4. So first one is ln x. Oops. Ln x has graph of the form like this. Yeah. And y x-axis, this is the one. Y equal to 1. Okay, this is y equal to 1. X-axis is y equal to 0. And y-axis, this is the y-axis. So the region is this guy. And then we start rotate it about y-axis. So what we get is a three-dimensional or solid of revolution of this form. Okay. Let me just do this part again. Yeah. It is solid. It is. There's no space between. Okay. So then the volume here is going to be from 0 to 1, limits of the integral, pi, the function here. The function here is y equal to ln x, but we have to write x as a function of y. We know that the inverse of this, or put e both sides as exponent of e, we'll get e to the power y is equal to e to the power ln x, which is x. So x is a function of y, so we write e to the power y squared dy. This is pi integral 0 to 1 e to the power 2y dy. How we can integrate this one, evaluate this one? Well, we can use substitution here. So 2y equals to u, du is equal to 2 dy. Okay, and then if y is 0, then u is 0. If y is 1, then u is 2. So we go 0 to 2 of e to the power u, 1 over 2 du. And that will give us pi over 2 e to the power u, go from 0 to 1. Then fundamental theorem of calculus tells me that pi over 2, that value is e to the power 1 minus pi over 2 e to the power 0. So it will be pi over 2 e minus 1. That's the area or volume of this solid of revolution. So the key point to have in mind when you working with rotation about y-axis is that you have to write everything in terms of y, and your integrand is going to be a y integrand. So everything will be, the variable will be y.